but let me tell you a data story. I mentioned that in that first quote, I mentioned how important the customer is, how important data is. Everything starts there. So last year, someone mentioned to me Vision Zero. And I wondered what this Vision Zero thing was, and I realized it's all surrounding this notion of road safety. Vision Zero started, as I understand, in Sweden. The Swedes decided they needed to cut down on the fatal and big injury accidents that happen in Sweden. So they focused their energies on how do they do that. And there were really two aspects to what they were trying to do. They were trying to understand, they were trying to re-engineer roads to make them safer. They were also trying to change the behavior of drivers. And now engineering was a very important part of both these aspects, changing behavior and making sure that they guided people and slowed people down, for example. Speed kills, obviously. Now that notion of Vision Zero is spread throughout the world, and the US was a little slow in moving forward on that one, but now it's a very big focus over here. How do we cut down on fatalities on the road and serious injuries? So I was really interested in that because fundamentally that struck me as a geospatial question. You know, when we go back to that notion of something which happens somewhere, or the geospatial notion, a place on Earth, well, accidents happen in particular places. So I decided it was probably a good idea to explore this a bit more. What is the problem, and what's the path that people currently do to try and get to a solution? So I sat down with some engineers, some traffic engineers, and asked them their workflow, and they told me where everything starts with the police. The police go out and they collect data on an accident. So they'll collect where it was, they'll collect what happens, whether there are injuries, etc. So police reports are collated, and that's the basic data set that these traffic engineers use. So they wanted to, so there are lots of technologies out that allow them now. GIS is one, and various geospatial platforms. You know, we can visualize that data easily. And here's one example, and I'm not going to talk technology apart from the last slide in this. This isn't a technology conversation. This is more a conversation about where the geospatial world moves. So I'm not really going to talk anything about technology. But this is a way to visualize data. And I really wanted to underline the fact that historically we've really lived in a two-dimensional world. Why? Because most data that's been collected historically has been two-dimensional, i.e. an X and a Y. It happened at this particular location. And for traffic engineers, the first question they ask is where are the most problematic intersections in this case in any particular place. And this is in Chattanooga in the US. And what we've got here is essentially a visual representation of where all that, where the most problematic places are for collision. So you'll see here we've got a combination of things. We've got heat maps, which is the coloring obviously there. The red obviously indicates higher collision rates, and the green area is less. And then we've also got clustering. So we've got the actual number of collisions that happen at each place. So that's a really important first step for the traffic engineers, to actually have a visual representation of where the problem places are in that city. We've also broken some of this down in this dashboard, some of the other data down. So I want to filter the data. So it's not absolute, it's not for the traffic engineers about where the absolute collisions have occurred, the absolute numbers I should say. They're really more interested in fatalities and serious injuries. So we may have an intersection where there were only 20 crashes versus 200 somewhere else, but 50% of those were fatalities. That's a very important thing for traffic engineers, because they want to obviously focus on this notion of Vision Zero and cutting down on the number of injuries and deaths. So this information that's presented here is a filtering of what really the police have collected. So you've got the type of collision, whether there was a fatalities or not, what date it happened, etc. So as you're trying to sort of use data to tell that story, two-dimensional data is really valuable. It starts a process of isolating those areas. But the key question I asked those traffic engineers was, once you've found this information out, you've taken the police data that's been collected, you've mapped it, what do you do next? And they looked at me and scratched their noses like I'm doing here and said, well, we drive out to those most problematic intersections. We'll actually stand on the corner and we'll look around. We'll see Is it overhanging vegetation that's causing the problem? Is it a broken guardrail? They'll assess that particular location. They'll take measurements and do various things on site. So they go into a diagnostics phase. And the diagnostics phase involves, again, the first place is let's go look at that intersection. My question to them was, suppose you could see that intersection on your computer. And they'd really not had that conversation before, at least the guys I spoke to. And they said, well, that would be wonderful. We wouldn't then have to drive out to these various places and save us a lot of time. This isn't the greatest of screenshots, I apologize, actually taken from a video, but this is actually LiDAR data of one of the intersections on that previous map. So this is actually in Chattanooga, and this is a three-dimensional view of that intersection. So we can explore in a web browser this view. We can actually see if there is an overhanging vegetation issue by actually zooming in to the tree there and looking around, assessing it. So we can actually assess it in 3 dimensions. The data here was collected with a combination of drone and terrestrial LiDAR. Somebody drove down that road and collected LiDAR and imagery as they drove down that road. So I mentioned that the speed that we can collect this 3-dimensional data. So we've really recreated that intersection digitally. And that's the power of 3D. And when you hear about this notion, and I don't really like the term digital twin, I like the term digital reality, because digital reality gives us a sense of place. It gives us a sense of what does that intersection look like. The other thing that you can't actually see here is we've included GIS data. So there's an actual green point in the middle here, which was actually where collisions have happened. And there are a whole load of points here. So we can actually include additional information that's not available to those guys if they were standing in the field. They can see in this interface where all those collisions happened, what type of collisions they were. So it gives them ever more diagnostic information. Another component to this, which is only recently available, is we can now vehicles have got sensors in them. So we can actually collect information from the vehicles that are driving through that intersection. And I was interested, I was actually chatting with a company based in England that are doing this work, and actually most of the work's actually done in the US here. And they collect data from the sensors on these vehicles, and ever more vehicles we know have got sensors on them. But they weren't just collecting the location of those vehicles as they moved to the intersection. They were collecting information like harsh braking, harsh acceleration, whether seatbelts were worn, etc., etc. So again, we can overlay that data in this interface to show those particular locations in that intersections where people were harsh braking. So this is all evidence that these guys can use to understand better why these intersections or these particular intersections are so problematic. So again, the power of data. We've spoken about 2D patterns. We've spoken about 3D giving a sense of place and these additional data sets that we can use to help diagnose the problem. A third element to this, again, in conversation, was, well, again, now we're collecting real-time data, or at least time-based data. So that's the 4th dimension of this location data. So I've called that the real-time pulse. So yeah, we can actually show traffic moving through those intersections over time. And again, all evidence for these guys to understand better the whys of these particular locations. So we're using 2D, 3D, and 4D to help them diagnose problems. One other thing I'll add to that, and this, I use this image, even though this image is, suggests movement of vehicles, what this image actually shows is actual collisions in that intersection. So traffic engineers were less bothered about this because insurance companies, the police, other groups are really interested in, well, let me see examples of collisions that happen there. We've actually got LiDAR, handheld LiDAR data here, which shows those vehicles actually in collision. So one of those has actually got a motorbike that's smacked against the side of it. So again, this is more information we're collecting, which is location-based around the whole world of collisions. One other thing, predictive analysis. Since we're now collecting all this data, we can push this data into AI algorithms, and we can actually use that to make predictions. So we can use data, for example, to predict collisions in a particular day based on weather, etc., etc. So we can predict ahead of time what's actually happening on the road. But we can also predict from going back to the traffic engineers example. Suppose I put a roundabout at that intersection. What predictively would that result in? What do we know would happen if we did that? You know, we can put all these variables in. It would cut the speed down, etc., etc. But if we're going to try and make predictions around fatalities, etc., there's ways we can use these combination of data sets, focus on that place to actually understand the effects of a treatment, as the traffic engineers say. So that's kind of a customer-centric, data-driven story, and it's what I would say is it's a kind of a 2.0 story, that one, because we're really focused on A, the customer, and B, telling stories, or at least building stories around that's powered by data to solve particular problems.